Hello everyone and welcome to our sessions on AI. So we had been doing some basic image processing operations in the previous sessions, but in this session we'll be going to do a very good or very important image processing operation. So the image processing operation that we'll be doing today is called as edge finding and contouring. So what is this edge finding and what is this contouring all about? We'll try to understand. So very important to understand is whenever you're trying to have something in your image, so you have a couple of nothing but a couple of rectangles or a couple of different images or a couple of different parts in your image. So it is very important to find out the edges. So what are edges in terms of mathematical or in terms of your image processing is, see, all the pixels here within this, that is nothing but the last pixel here is 255. But the pixel here is 0. So whenever you have variation in the pixels, so whenever you can find variations in pixels either in the form of horizontal way or a vertical or a free line way. So even if you have free lines like this, so if you have curved spaces also, so if there is any variation between the intensities of the value, so those parts are called as edges. So it is very important to find out edges, because if you are having two different images or two different objects in a particular image, so if you want to find out the edges, so most of the AI based image processing operations works on this principle. So if I have if I have an image, so best example is Google Lens. So whenever you take an example of Google Lens, so if I have 1, 2, 3, 4, 5, 6, that is number being written, so how will this particular image be understood as a number? So what the operation that we do is called as OCR, or optical character recognition. So whenever you take in an image, so that can fetch out the text inside that image. So if you see an image of a phone number, so obviously you can write down that phone number, right? So that is an example of image processing based AI that is in the picture. So most or 99% of all the operations that we do in AI based image processing, we need this operation that is nothing but contouring as well as our edges. So what is this edges? First we'll try to understand. So what is this edges is nothing but, edges is telling you how the surrounding pixels are getting differentiated. So you can see here, there is an edge factor here. So there are white pixels and there are black pixels. So you are able to draw a small boundary stating that this is the one, that is nothing but a numeric value of 1. So this is the numeric value of 2, 3, 4, 5 and 6. So that is how you are able to draw. So what is edge basically is, so I will just use a freehand drawing to depict. So what edges are doing is, it is telling you this is the pixels that is surrounding the edges. So I can actually draw these edges. So this is the pixel surrounding the edges. So you can actually draw the edges here. So this is how an image processing algorithm works. So what it does is, particularly it will choose the variation between the pixels, that is the black and white pixels, and it is able to get this particular one. So it is able to pick out the one from the entire image. So there are different aspects in this image. So there are black lines, all these things. So each and every part is recognized as an edge, and that is how your image processing is working. So first thing is, you need to understand the definition of edge. So edge is nothing but whenever there is variation in intensity. So whenever you have variation in intensities you can call it as an edge. So there will be a different part. So if I have, if this is not clear, so what I can tell is, I can take in a filled circle or a filled rectangle. So if I can take in a filled rectangle, obviously you can tell that the filled rectangle is telling you that here is the edge, because all the parts within this rectangle are filled with red, and outside everything it is nothing but my white color. So all this part belong to one particular image and all the other parts belong to other part of the image, or it is a sub part or a different category. So similarly this rectangle also, so since you have these different lines here, so they're all considered as edges. So edges are nothing but how you have your edges in lines or edges in boundaries. So if you have two different places, you draw boundaries. So edges are nothing but boundaries that you can use for a particular image. So if you want to find out different boundaries like people, animals, objects or anything, so these edges will play a major role. So how do you find out edges in an image? It is very simple. Using OpenCV, you have a function called as canny edge finder. So canny is nothing but a mathematical operation. So canny edge finder will find out what are all the edges are there in our particular image. So basically what you need to understand is edge is finding out the boundary. So you can find out the different boundaries. So if you have 4 rectangles or any kind of different figures, it will try to find out the boundary using the variation in the pixel. So how do you find out boundary? You have the variation in the pixel. So that is how it is for finding out the boundaries. So you can find out any shape boundaries, freelance boundaries. So any shape of boundaries it can find out. So why do you need this particular boundaries to be done is to basically help you in understanding what are all the different components are there in one image. In one image you might have hundreds of components available, like you have hundreds of small images, large images, and a series of images, like there is some coin in the image. So if you want to find out all the edges that are there, or even recognize text inside an image. So if I have a photo of my text document, so if I want to recognize those characters, I need to find out where that character is present. So I need to find out the edges. So finding boundaries is very important in order to locate as well as to change some parts of the image. So how do you play with that is, now what I'll do is I'll save this image only. So what I'll do is I'll save this image as only like IM1. So let us try to find out the boundaries. So we need to find out 1, 2, 3 rectangles and 1 star. So how do I find out the boundaries is very simple. So I will import CV2. So after importing CV2, what I need to do is, very important, this function also applies for a grayscale image. So what is grayscale image? Grayscale image is an image which has only 2 intensity values. That is nothing but from black to white, but it can vary. So you have different gray levels also. So I can call a variable called as image is equal to cv2.imread. So it will read the image. So my image name is im1.png. So this is my image name, so which I have saved it in the same directory. So not a problem. So if I want to show you the image, it is cv2.imshow. Okay, image. Then I need to tell which variable it is getting stored. Image is the variable. So right now, if everything is right, yes, I can see this particular whole image. So this is available here. Okay. So this image is available here. So I can see this image. Next, my task is to find the edges. To find the edges, it is very important to convert your image to grayscale. So 2 methods I already showed you. Either you can use 0 here, or you can convert it into a grayscale image using the function called as cv dot. You can use the function, that is default function, cv2 dot cvt color. So cv2 dot cvt color. So then you need to use the image which you want to convert it into grayscale. So the function is cv2 dot color underscore bgr2 gray. So bgr2 gray. So this is the inbuilt function to convert it into your grayscale image. So if you want to see that image, you can copy this, and you can just print out or you can just show out the gray image. So you can see here, you can see the gray image here. So since it is a black and white image, it is not making any changes. So if you have a color image, you can make those changes. So now I need to find out how many edges are there. So what I will do is I will try to find out how many edges are there. So edges is my variable. So what I will do is cv2 dot canny function. So canny function is nothing but it will try to find out the edges. So canny is a mathematical function which will try to find out the edges. So from which image you want to find out the edges? From gray image, but I need to tell which is the maximum and minimum intensity. So I can tell that the minimum and maximum intensity from 30 to, you can give it as 200. So this is fine. So you can give whatever you want. It is not a problem. So what you can do is you can see the edges by cv2.imshow. You can copy this part. Okay, you can copy this part. Okay, cv2.imshow. If you want to see the edges. So does this work? We'll see. Wait. cv2.imshow. We want to see the edges. So I will call it as edges. So then what I will do is I will try to print out the edges. So does this work? We'll see. Yes. So you can see here. These are all the edges it found out. So this is one edge, second edge, third edge, and fourth edge. So can you make out what is happening? So you can see that different amount of edges are being found out. So these are all the edges that are being found out, and the major important factor is, okay, now I found out that this is one edge, these are all some black dot, these are all the edges. So this is the second, and there are there are so many edges or boundaries here. So edges is just telling you the boundaries. So what are all the boundaries that are available? But we need to go into another concept called as contouring. So what is contouring is nothing but, contouring is telling you that whenever there are edges, so if all the edges get joined and form a figure, so that is called as one contour. So you must be aware of contouring in geography. So if you have different places, so you can find out different contours. So what is a contour is, whenever I use my any kind of figure, for example, I can draw a pentagon, I can draw a hexagon or anything. So whenever I draw something, so it is all made up of boundaries. So what is edges and what is contouring, you need to understand. So your edges is nothing but this imaginary line. So this, not an imaginary line, but the line which is telling you the boundary between surface 1. That is nothing but the boundary 1, or the points within the boundary and the points outside the boundary. So this is nothing but area 1 and area 2. So this is the boundary that is separating area 1 and area 2. This is called as an edge. So this black line is called an edge because there is variation in some pixels. But what is contour is nothing but the area is called contour. So this entire rectangle which is present here is called contour 1. So this is contour 1 and this is contour 2. So try to understand this. Edge is nothing but the boundary, but contour is nothing but the area. So this entire rectangle is contour 1, and the outside, all the parts outside it is called as contour 2. So what is contour is nothing but, area under the boundary or area under the edges. So this is what is my contour. So how contouring is helping me in all my practical tasks is, so if I want to write my digit 1 here, so I will just make it a very big digit so you can understand. So this will be my 1 digit here. So what happens here is, first it will try to find out the edges. So how it is finding out the edges? Based upon the variation in my particular value. So if I want to find out the edges, it is pretty simple, as I told you. So what it is going to do is, it is trying to find out all the edges. So the difference in pixels it is finding out, and then it is recognizing this as 1. So if I want to print out this particular data, or if I want to use it in my ML algorithm, I don't want the edges here. I want the colors or pixels or intensities within this particular edge. So what I want actually is the area or the pixels inside this particular boundary or edges. So this area is called a contour. So this entire area which contains all the pixels information as well as intensity, this is called as contour. Edge is nothing but the line which is separating all the different intensity values. So the area which is within this edge is called as contour, and the area outside is also contour. So you have these edges which are separating different contours. So that is how you need to understand. So contour is the area, edge is the line which is separating different variable intensity pixels. So this is how you can use it in various principles. So if you have face recognition, so what you will do is you just want to recognize the face. So how do you recognize the face? So if you have a face of a person like this, so you draw nothing but edges first, then you take the area inside this. So this area will become the contour. So contour is very important because it is giving us the area that is nothing but the part of the image which contains our information within the edges. So this is very important because we will be using them. So how to find out the contours or how to draw contours, it is pretty simple. So you need to use a variable called as contours. So contours is my variable. So then it is hierarchy. So two variables. So we have a function called as cv2.find_contour. So yesterday I told you we had another function. So that was returning a true or false. So what is hierarchy is nothing but, see, one thing in contouring is, if you have your edges that is a very thin line, for example, if your line is very thin, so if it is a very small line or a very thin line, so this is a fairly thin line. So the contour is difficult to find out, or the amount of edges it is finding is less. But if you consider a use case where contour is bigger, so then it has more probability of finding out. So it is very simple. If you have a bigger line, it is easy to find out there is a bigger line and there are edges for a bigger line. But for a very thin line, it is difficult to find out the edges and boundaries. So that is what we are talking about. So hierarchy is nothing but which is the most significant figure here to find out the contours first. Then it will try to find out more and more contours. So what is it doing is, when you find out the edges, it is telling us which is the most significant edge. So you can see from this figure. So okay, if you just find out the edges here, you can see that these are all the major edges. Okay, these are all the major edges. But these 3 points are not the major edges because they are all least hierarchical edges, or they are difficult to find out. But more prominently, these are able to find out. So it is nothing but if you can see a big tall skyscraper, it is easy to find out. So hierarchy of that will be greater. But if you find out a small building, it is difficult to find out amongst all the like the big buildings. So the hierarchy will be less. So hierarchy is nothing but the ease with which it is finding out the nothing but our values, or ease with which it is finding out our contour. So contour is nothing but our area. So we have 2 variables. One is called as contours and the other one is called as hierarchy. So we are not interested in finding out the hierarchy. We are interested more in finding out the contours. So what it will do is cv2.find contours is the function. So C is capital here. So how will it find contours? We have already the edges defined here. So we have the edges defined here. So using the edges, so we know that here is one edge, second edge and third edge. So using this edges function, so using this edge, it must find out the areas. So it must separate the edges and it must find out areas. Here what we need to find out, 2 rectangular areas and 1 star area. So they are the contours. So cv2.find contours. So from which it will find contours? From edges. So edges is nothing but it has detected the edges now. So now I need to find out how many contours are there. So what it will do is cv2.retr external. I should give a command called as retr external. So what is this command doing is, it is returning external contours. So what is external contour is, whenever I have a big rectangle here, so if I have small rectangles inside this, so these will not be found out. Okay, so only the external contours will be given out. So if I have anything within this particular data also, it won't be found out. Why? Because best example is if you are trying to find the face of a person. So you have a person, then you have eyes, so then you have mouth also. So if you want to find out the contour of the face of the person, yes, it will find out and it will draw a boundary like this, stating that this is the contour of the face of the person. So if I don't give this return external, what it will do is, it will try to find out small contours also, then it will separate my whole face and it will give me different parts of my face. So that I don't need. I just need one external contour. So this is the external contour. So inside that, whatever is there, it won't inside this, even if I have 100 rectangles, it is not going to recognize these edges and find the contours. Edges will be recognized, but contours will not be found out. So what it is telling is, it is trying to find out only external contours. So if I have 2 rectangles here, this is one rectangle, this is one rectangle, it is finding out. So if I have a small rectangle inside those two will not be considered for contour. So very important to understand that. So what we are dealing with is external contours or external areas. So then we need to mention one more thing, cv2 dot chain approximation none. So what is chain approximation none is very important to understand. So what we are trying to do here is very simple. What is this chain approximation none is, whenever you are trying to find out the contours or anything, the major task is, how do you find out a particular point? You need to have the x and y coordinates. So very important. So you need to have the x and y coordinates of all the 4 points or 5 points or 6 points. So it depends on the figure. So if it is a rectangle, I need x1 comma y1. So here I need x2 comma y2. And here I need x3 comma y3. Similarly, I need all the 4 coordinates x4 comma y4. So only if I have all those 4 coordinates, I can tell what is my area or how my area looks. So contour is not just for rectangle, it can be done for an uneven figure also. But for all those things, you need nothing but the coordinate points. So coordinate points are very important. So that will tell you how is the boundary being defined in our image. So you should tell from which pixel to which pixel. So x1, y1, x2, y2. You need to tell the coordinate points to define the contour. So chain approximation none is telling that you need to include all the points. So there is one more method called as chain approximation simple. So you can give chain approximation simple also. In that case, what it does is, it takes in only the points of the topmost and the bottommost. So this is also there. So in chain approximation simple, it will take the topmost and bottommost points. But in the case of chain approximation none, it will take all the points that are there for the image. So it doesn't take only the 2 points or 1 point. It will take in all the points for this image. So that is what your chain approximation none is doing. So now what we have done is, we have told the function that please find contours, that is areas. How will it find contours? Using the edges. So there are so many edges. So please get me those areas or the images in which areas are there. So what you need to do is, you need to print out all the contours. So how do you print out all the contours is, you need to use nothing but, you need to first draw the contour. So what is drawing contours is, area is found out, but how will you know that area is being found out? So what you need to do is, you need to actually draw contours. So what is drawing contours? Draw the boundary. So how will it draw boundary? You have a function called as cv2.drawContours. So please be clear with this. Contours is nothing but the areas, but how will you know that some area is there? See, the computer algorithm found out that there is some, these are all the contours or the areas within my figure using all the edges. But how do you manually see it or see it with your eyes is nothing but cv2.drawContours. So what this will do is, it will try to draw all the contours in the image which it has recognized. So I want to draw contours in which? I want to draw contours in the image which I have taken. So that is what I am going to do. I am trying to draw the contours in the image which I have taken. So what I should draw is nothing but the contour. So this is nothing but the variables here. So this variable is storing all the xy coordinates of the contour. So it will draw all the contours in the image. Then I will use -1. So -1 is telling me draw all the contours. So if you use 2, 3 or something positive figures, so it will draw first 2 or first 3 contours according to hierarchy. So that is why you need this hierarchy. So if I want to draw all the contours, I can draw, but I need to mention which color my contours I should draw. So which color should I draw? I should draw the color of nothing but green. So it is represented by BGR. So if I want to draw green, 0, 255, 0. So that is how I can draw a contour. So I can even mention the thickness of the line. I will mention the thickness of the contour line as 3. So very simple. So we found out the edges which were telling that these are all the edges that are there in our particular image. So what are all the edges? So this is all the edges I will get. But edges are only telling the boundaries, but I want the area inside the boundary so that I can use them in my operation for finding out the faces or for finding out the numbers or text information or any information. So that is why I need this area. So to store these areas, I need to find the contour. So how do I find contours? Using the edges, I will find contours. I tell that I need external contours and I need all the 4 coordinate points. After I get the coordinate points, I need to draw it in my image for a person or for an external person to understand. That is why I will use cv2.drawContours, which will draw contours on the image, original image. So contours is being drawn. So then I am drawing all the contours, that is -1. So then 0, 255, 0 is BGR, green colored. So 3 is nothing but my thickness. So this is what it did. So if I want to display the contours, it is cv2.imshow. So contours are drawn, but I want to display the image. So contours is the name of the window. So if I want to display, I will display the image. So now what I will do is I will try to run this code and will see what is exactly happening. Yes, so you can see here exactly rectangular shape, and exactly star shape. So all these things have come in green. So this is telling you how my contours are being drawn. So these are all separate areas now. So 1, 2, 3, 4, 5, 6, 7, 8. 8 contours have been found with different areas. So I can use these individual areas and try to do some image processing operations also. So this is how you draw contours in an image. But let us change the image actually. So I will see with the leaf. So how will that leaf.png, leaf.jpg look like? So I will just run the thing. So see, exactly according to the boundary, it has recognized the leaf. How? Because variation in the intensity, it found out the edges. But after finding out the edges, I want this area, this contour area I want to find out. So then I can see how many contours are being formed. So this, you can see this is the edges, so it can see. But important thing is it didn't draw green lines here because I told only recognize external edges. So this is the beauty of contouring. So if you want to print out how many contours have been found or what is the hierarchy, so you can print out the hierarchy also. That is not an issue. So what it will print, you can see. Okay, I have done a name error. 1 second. So this is the small spelling mistake that I have done. So okay, so it is giving me the hierarchy stating that how my pixels are varying or how my contours are being detected. So these are all nothing but what is the hierarchy that is being told. So this is nothing but in the form of mathematical matrix. You don't need to understand that, but you need to understand how actually you are trying to contour your images. So contouring is this operation. So I hope you understood contouring operation. Next operation or the next start of steps will be a small simple tutorial on drawing something. So drawing is nothing but on the image you can draw some like how you do in your editing apps. Actually what you can do is you can draw some lines, you can draw some rectangles, you can draw some edges. Like how we draw some contours, we can draw on our own whatever edges what we want to take or whatever things that we want to do in like our programs. So you can draw whatever identities or whatever free figures or 2D figures which you want. So what I will show you is how to draw a simple line. So once I have read this image, that is leaf.jpg, so I want to draw a line. So cv2.line will draw a line. So on which I want to draw it in the on the line that is image. So I need to mention the starting color and the ending color. So starting point and the ending point. I will start at 0, 0, that is the coordinate. So this is nothing but a small straight line. So I will end at, okay, I will end at around 1000, 1000. So 1000, 1000 is the ending point. Starting point is 0, 0. So I need to mention the color. So how do I mention the color? I want blue color. So BGR, always remember BGR. So B is for blue, G is for green and R is for red. So I will draw blue colored one. So that is how I draw it. And thickness. So you can choose thickness as 4, 5, 10, 100. So whatever you want. So this is how we can draw a simple line. Choose the starting point of the coordinate pixel. Choose the ending point. Choose the color and choose the thickness. So if you want to see it, cv2.im show. So what this image is storing is whenever I have taken the image, on that image I have drawn a line and that is getting back, stored back in this image variable. So I want to show this image cv2.im show. If you want to see the image, it is simple. So you can see the image directly. So if you want to see the image, I need to type the window name. So I will type it as line. So then what I will do is I will just include a small point that is nothing but image. So this is my image and this is the line that I have drawn. So you can see here starting is 0, 0. The ending is 1000, 1000. So 1000, 1000 is somewhere down. So that is how you can draw a simple line with the help of nothing but OpenCV. So OpenCV allows you to draw something. Why you want to draw on an image? Because if you are a doctor, you want to show some bone being broken, so you can show. If you are an architect, you want to show the boundaries. So what is the exact boundary of a particular place here, so that if you want to show. So then if you want to show nothing but if you want to show important thing that is area of interest that in an image that you can show. So this is how you draw a line. If you want to draw a circle, it is similar. So cv2.circle is the command. So if you want to draw a circle, what you need? You need the center coordinates of a circle. So after image, you need to give the center coordinates. So center coordinates might be 200, 200. So that is my center. So then you need to give the radius. So what is radius? Radius is telling you what is the exact radius of the circle. So I will give my radius as nothing but 50 is better. 50 is my radius. Again, blue colored, thickness is 4. So if you want to draw a circle, cv2.circle will draw a circle for you. So these are all the basic simple operations. So you can see here the center of the circle was taken as 250, 250 or whatever coordinates that I gave. So the entire, the entire radius I have taken as at 50 units. So this is how I can draw a small circle inside my image. So cb2.circle will draw a circle. So these are all the interesting small but interesting things that you need to know. Okay, so then we have another point that is nothing but drawing a rectangle. So rectangle we'll be using every time because we'll be using it in many of the operations, like how to find a face inside my image, or how to find the area of interest. So if you want to find a person in the picture, so you will use this rectangle. Why we are drawing this is to understand, to make the person who is seeing this image understand. So if obviously I can see some object, but if I want to notice it, so the best example is obviously the news channels will make you, like, they'll put circles or they'll put rectangles for you to like look closely onto that part of an image so that you can see something of greater importance. So cb2.rectangle, you can draw the rectangle. Here also you need to give the 2 points. So what is the starting point and what is the ending point? So 100, 100 is my starting point, and 200, 200 is my ending point. So this is the left topmost and bottom and the bottom right point. So this is the top left, bottom right points. So again, blue colored image. So if you want to draw red color, it is 0, 0, 255. So this is what you are trying to do. So you are trying to draw a rectangle. So leftmost point, bottom right point, red colored, and the thickness is 4. So you can see here. So you have drawn a rectangle, but since I have given 100, 100 to 200, 200, it has become a square. So if I give 270, 200, so this is the top left point, bottom right point. So that is how it is drawing a rectangle here. So very important to understand here. So these are all the basic drawing operations which you could do with OpenCV along with contouring and our edge detection. So in our next tutorial, we'll be doing a project which involves handwriting recognition or number recognition. So that will be a good understanding of why we learnt drawing as well as why we learnt our contouring as well as our edge detection operations. So this is very good thing to understand. So I hope you have understood much of this project. So thank you.